Okay, I'm going to try to do another little take on this stoichiometry, because this is probably the most difficult part of this course, and some of you're not showing your work, and I'm not sure that you understand what's going on. But anyway, on question 1, most of you got it correct. You can interpret a chemical equation several ways. You can talk about it on the molecular level, meaning something that you can't see as far in terms of molecules, or moles, which is a macroscopic level, which is something that you can actually measure in the lab and see for yourself. So you could say 2 moles of aluminum react with 3 moles of chlorine to give 2 moles of aluminum chloride. And I don't want to mix the units. I won't say 2 molecules of aluminum react with 3 moles. I wouldn't do that. I have to keep all my units the same. So if I'm using moles, it has to be moles. The numbers 2, 3, and 2 must mean moles. If I'm talking about molecules, it must be 2 molecules of aluminum, 3 molecules of chlorine, and 2 molecules of aluminum chloride. And I can also talk about a large number of molecules, meaning what the actual mole equals. The count of molecules is 6.02 times 10 to the 23rd molecules. That's like saying if a mole is equal to a dozen would be like 2 dozen of aluminum react with 3 dozen of chlorine, which give 2 dozen of aluminum chloride. And we know that the dozen is 12. So if I'm saying this was 2 dozen, then that would be 2 times 12 is 24, or 3 times 12 is 36. And so likewise, I'm saying the actual number of molecules, if I have 2 moles, it would be 2 times 10 to the 2 times 6.02 times 10 to the 23rd molecules of aluminum. That would be another way to interpret it on a macroscopic level, but in terms of molecules. Okay, the second problem, everybody except I think one person missed this problem, the second problem. So I'm not sure whether you understand it or not. So I'm trying to clarify it here. Okay, in any stoichiometry problem, you always start with what's given, meaning the amount that you could actually weigh out. And you could actually weigh out 1 mole of nitrogen, because nitrogen, 1 mole is 14 grams, or 14 times 2, I'm sorry, because the molecular weight is 14 times 2, because there's 2 of them. So I physically know this measurement. And so now to convert from moles of one thing in a balanced chemical equation, then I take it's basically a ratio. For every 3 moles of hydrogen, I have 1 mole of nitrogen in this balanced equation. So if I'm using this equation, that would give me 3 moles of hydrogen. And see, I know the answer is right because the ratios that you did in the top problem, Q1, I put them such that I cancel out what I don't want. See, the 1 mole, not the 1, but the moles of nitrogen cancel with moles here. And so my numbers that I do in my calculator are 3 and 1. That gives me 3 here, but my unit is moles of hydrogen. So in the second one, I start with 0.6 moles of ammonia, and based on the balanced equation, I have 3 moles of 1 mole of nitrogen per 2 moles of ammonia. So I'm going to put the 2 moles from that ratio, this is basically a conversion ratio from the balanced equation. I'm going to put the 2 moles of ammonia on the bottom, because I want this to cancel with this. And then what's on top is what's going to be in my answer here. So this will be moles of nitrogen. Likewise, on the last one, which mostly you got 1.4 moles of hydrogen, and my ratio for my equation, I look at my hydrogen, I have 3, and so my 3 moles of hydrogen are going down here because I want the moles of hydrogen to cancel, and then the 2 moles that come from here will be here. And so that would be my unit, and then my number would be from the factor part, 1.4 times 2 divided by 3 would be my 0.93.